Okay, so in this one we're going to be talking about conditional expressions. So basically what this does is it allows your program to go in, well, a different flow. So what you can actually do without even having it in a function is you can just go cond, let's say greater than, let's say 3 and 4. And then if that's happened, you can say uh, 3 is bigger than 4. And if that's not true, you can say 3 is less than 4. And finally, else 3 is equal to 4. I mean, this is the obvious last case, right? So essentially what a const statement does is questions and answers. So here's the first question inside of this larger block. What happens is if this part is true, the entire conditional statement evaluates to this. On the other hand, if this is not true, then the entire block is then um, deleted off. And then the conditional statement simplifies to whatever this is. Okay? And then the exact same process continues. It checks if this is true. If it is, then the entire conditional statement evaluates to this. Otherwise, again, this line gets cut off, and then we're at an else. If we get to an else, then no matter what, we're going to be executing this, which means that the entire const statement evaluates to this, no matter what. But let's see what really ends up happening. So if we run this, we notice that this code over here never runs. This code never runs in the top black outlined thing, simply because 3 is not greater than 4, so the conditional never gets here. In the same way, over here, this is run because 3 is less than 4. So as soon as it gets here, it realizes that this is true and executes this. The entire conditional statement evaluates to this and prints it out. And that's generally how conditional statements work. That's literally all you need to know about how conditional statements work, because now what you can do is you can put them into your program. If we define, let's say over 100, let's say over 10. So we can have a value x, and we can put in a condition. Well, if it's over 10, so greater x than 10, we can say x is bigger than 10. Otherwise, we can produce else x is less than 10. Now, of course, this is a very simple example, and if I run this, that still happens, and I can say over 10. Oops. Let's say 40. So if I do this, it prints out x is bigger than 10, simply because it got here and everything was fine. If instead I do 4, then the first line never executes, simply because x is less than 10. So this entire block gets wiped out, and we execute the else. Alright, so conditional statements are actually pretty easy. And they can be very useful in the sense of making sure that the values that you have are actually the ones that you want. For instance, in a previous video, I think I used one to make sure that the data we were dealing with is actually what we needed. If you want to do this, what you can do for your conditional statement is, let's say that we have a struct. Define struct. We can do account, and in the account we have a name, we have amount, and we can say account number, like ID number. So, and we can specify that an account has number, and then let's say a natural number, because 90 should be natural, as in bigger than 0 and an integer. So what we can do is we can define a function that checks if an account is actually an account. Now, we already have a function, remember, that checks if something is an account, right? And it'll return, or it'll produce a true or false depending on whether it's given an account. Or so we can have a function that says proper account that type checks these three. So let's say test as our account, cond. First we can check, well, is the thing actually an account? We can go account. We can do a not. Test. So if it's not an account, then we can finish the function by saying, test is not an account. On the other hand, this means that if we get to this part of the condition statement, the first one must have been true. I mean, false. So, in which case, test has to be an account. Because think about it, if test is an account, then this part evaluated to true, and then since we're noting it, that's a false. So, if test wasn't an account, then this would have been false, the not would have made it true, and then the program would have finished. So right now we can assume that test is an account. What we can now do is we can put in an and then we can check each of the inner workings. So we can check is, account, is this a string? We can check account dash name of test, and we can check is it an number, count dash amount test, and we can check is it well, this would be an integer, account should be integer, count dash ID of test. So all of this would work to make sure that an account, let's say we define my ack to be Jack Black. The amount should be, let's say, 654, and the ID we can try 20.3, and this should fail. So if I run proper dash account on my ack, we should get back the founder clause is only one part. Oh, that is a problem. So this is one of the main problems. You will do the entire first part. So basically all of this made sure that it's actually an account. Well, we had to do the output, and the output can be the given value is an account. Or we can proceed with whatever function we want to actually do to the account. So if I do this account, I spelled account wrong, and do this Jack Black. There's a lot of little syntax issues that come up. Such as this one. And more brackets. Alright. And here we go. So all question results were false. So this is essentially what happens when you reach the end of a statement that doesn't give you any true values. So it decided that, well, it is an account, so we don't have to do this part. And then it realized, well, this is false because this over here failed. The account ID wasn't an integer. So when this is false, there's nothing else in the cond expression. We should put an else case so that we can recognize when everything is done. So here we can say else, oops, test is not an account. So this would make sure that we're actually finished with the function. Because now we know test isn't an account. On the other hand, if we do this, then we can produce the given value as the account. On the other hand, it might actually make sense to just give back test, because then we can use this proper account test to use in a bigger function, and that way the bigger function can make the check using this, and if it is an account, then this just produces the actual test, in which case everything is fine, because let's say we have a function that actually does something to an account, like it modifies how much money is in the account. So if we define, or it produces an account like add 10 to an ACK, what we can do is we can plus, let's see, we can do a make account that has, for the first value, we would have to have a cont here first. You can check using proper account for whether it's an actual account. So we can do proper account account. If this is true, this should probably return true then. Then we can execute our adding function, like add 10. Wow. On the other hand, if it isn't a proper function, then we can say, well, this isn't, a proper account. We can say, well, this isn't a proper account, so we can't add 10 to it. And then you can do else can't add 10 to a non-account data type. And that would be essentially what you do. So you can see that the cont expression is very useful simply because it allows us to take different paths inside of a function. It allows us to choose which expression we want to execute. And that's that. So you should be able to use these inside of whatever functions you're going to define. And you should always remember to have an else case just in case nothing over here ends up working out. Alright? That's it.